Okay, our second part in just the basic descriptions of data as it relates to quantitative and qualitative and dependent versus independent is going to focus a little bit here on dependent and independent variables and understanding the differences between those, as well as then us looking at a typical kind of data file spreadsheet. Just kind of look through the different variables so that you can kind of figure out what a categorical variable looks like in a spreadsheet and what a continuous variable looks like in a spreadsheet, and also maybe just a little bit about how this graph was generated using Stata, and we'll go from there. So again, we're relating this back to this textbook, and the focus of this is on page 10. So dependent variables versus independent variables. So what makes something a dependent variable and something an independent variable? And I generally prefer to refer to these as the y variable or the outcome variable, and the independent variables as the predictors or the x variables. So a dependent variable is the outcome of interest that is being measured or predicted in the case of the health sciences, and sometimes that might be the frequency of disease or the life expectancy or the number of cancer cases per 100,000 in a given county, and then you might have all the counties in the United States. So we're usually focusing on a health outcome, but that's not necessarily what you have to focus on. There could be all kinds of outcomes that you're trying to predict or trying to see what might be related to that outcome. So independent variables, these are presumably responsible for determining or influencing the outcome if you're going to be using it for any type of statistical modeling or for making any type of comparisons. Oftentimes in biostatistics or in the health sciences, some folks will refer to these independent variables as the actual predictors, or well, usually I just think of them as the predictors. Sometimes you'll hear about them as risk factors. Sometimes they'll find that they're a predictor and then call them a risk factor later. Those are just different terms that folks may throw around and use, but ultimately there's a dependent variable which is plotted on the y-axis, and the independent variable, if it's by itself, it'll be plotted on the x-axis. If there's two or more independent variables, then their fits might be plotted against the x-axis, and that'll make more sense as we go later in the class. So in this example here, we've got a graph of life expectancy by median household income in the United States. So just looking at this graph first, what do we see? Well, we see that people, or this is county level data. Counties that have less money on average per person, so the median household income for the typical family and the middle family in that county, when they're low, the life expectancies are down here. And when you have wealthier counties, we see that there is what appears to be a trend, as you would expect. More income is associated with longer life expectancies in years. So the typical, or the kind of average life expectancy for a person in a county. Each one of these dots represents a county and represents the relationship between the median household income of that county and that county's life expectancy. So some of these counties, like whatever this one is a positive deviant. So they're living longer, but yet they don't have as much money, at least according to the data that were put in here. So, and then you have some counties that, are kind of outliers to the other direction. Something's wrong here. They're negative deviants. So, they, despite what they're making, they're living way below their life expectancies that you might predict for the rest of the United States using the rest of the U.S. data. But needless to say, we're going to actually kind of use some terms here. So, is life expectancy, as shown on this graph, is life expectancy an independent or dependent variable? So you should be able to answer that, and the answer is dependent variable. Now the next question would be, is life expectancy an outcome or a predictor? Well, let's look at our graph. Household income and life expectancy. So what's our outcome that we're focusing on? Well, we're focusing on life expectancy as the outcome, so that makes it a predictor. Or I mean, that makes it an outcome, and then the money that we're saying on average people make, that's the actual predictor. And then the axes. So this axis here, if you've not had much experience or forgot from geometry or basic math, this axis here is the y-axis, and this axis on the bottom here, this is the x-axis. So variables down here are our predictors, variables here are our outcomes, are our dependent variables, are y variables. So on the y-axis or x-axis, which one? Where is life expectancy? Well, life expectancy is on the y-axis. So that should be easy enough. Okay. All right. Next, we're going to compare multivariate versus multivariable. That's a set of terminology that some people will use. You might see it in the scientific literature, sometimes misstated, but generally speaking, most biostatisticians will use the term multivariable to describe situations where we're trying to predict a single outcome or a single dependent variable using multiple predictors. So if there is only one single y variable and multiple predictors, then we have a multivariable analysis. Multivariate is when there might be two y variables being predicted. So if there are two or more dependent or outcome variables being predicted simultaneously with one or more x variables or predictors, then that is a multivariate analysis. You may hear the term multivariate used more often than it probably should, and I'm not the only one who has that opinion. This article was from 2013 in the American Journal of Public Health, and it really puts a spotlight on multivariate versus multivariable statistical analyses that are used. We're focusing on linear regression in this and logistic regression, which we'll cover more in this class. But in their article, which you can read online, it's publicly available, you can see that a lot of folks make that mistake in calling some things multivariate that are really just multivariable. But I'm just introducing you a little bit into the basic terminology here. So we're going to now look at Stata, and I've got some data information to show you. So the graph, whatever that was made, it actually came from Stata using this command, scatter, and then it's a scatter plot, life expectancy versus household income. And we'll do some more tangible examples of this in the future here. I'm just showing you right for now on this kind of introductory level, how this is done. So it's a scatter plot between life expectancy and household income. In most stat programs where you've got coding, or even if it's point and click, the first thing it's going to ask you for is going to be, what's your y variable? What's your dependent variable? And then the next things that you type thereafter, those would be your independent variables or your x's or your predictors. So in this case, life expectancy is our y variable, it's our outcome. Household income is our predictor, and then it does this nice scatter plot for us. And then there's some graph editing that you can do to make it look prettier for your, movies or PowerPoints or whatever, scientific reports. I can also have it draw a line by a line of best fit. So I can actually do, let's see, scatter plot, life expectancy, and tell it to do a line of best fit. And it will then draw that line for us. We'll cover this more in the future. It's not as much of an important thing as understanding that life expectancy here is our outcome and this is our predictor. There is a way of seeing what the slope of that line is, so I can actually type in the command regress life expectancy household income, and it'll get me the slope of that line, which would be y equals mx plus b. If you remember the formula y equals mx plus b from maybe your geometry class or basic college algebra or something like that. So the y variable is our life expectancy. M is the slope of the line, which is our coefficient here, and this will all make sense later on in the class. And then b, the beta, y equals mx plus b, beta is our actual y-intercept where the line would cross. So remember, y equals mx plus b. So if I was to try to figure out what the life expectancy is for a community that makes $50,000, so I want to know what y equals. So y equals $50,000 times our coefficient right there, 0.0001249. So y equals mx plus b. So here's mx plus b, 71.68137. So what do I get? So a community that on average that makes $50,000, the median household income per year would make 77.93 years of life expectancy. That would be what their life expectancy would be. I can click on this and get the same command again, and I could change it to a community that makes $20,000 for their median household income for their county. So I've just switched the household income by one variable, and by losing that $30,000, they lose about 30,000 or about 3 years, 3.8 years of life expectancy. If you make a lot of money, $140,000, communities that make $140,000 US would be expected to have a life expectancy of 89.16 years using this particular formula. So that may not be accurate, but that's what the formula says. The formula also gives us these things called R-squareds, which we'll come back to later on in this class, that tells us that we understand 42% of the data. We understand 42% of the variability in the life expectancy values by just knowing household income. Now, as you know, there may be more than one thing that might be involved with life expectancy beyond household income. Maybe something like the percentage of the population that currently smokes. So now we've got a second X variable here. So current smoking, it achieved our statistical significance, and now we understand 47% of the variability in the life expectancy data. So here we've got two X variables. So now it's y equals mx1 plus mx2 plus beta. So we've got two actual X's. So is that multivariable or multivariate? Is multivariable because we still only have one outcome. So that concludes our little intro into independent and dependent variables. Thank you.